Something unusual is happening in the tropics right now, and the reason I'm paying close attention is not because we have a monster hurricane on the map. We don't. The reason is that one developing system is moving into an environment where the forecast could change very quickly, and Hawaii is now directly involved in the conversation. A tropical system in the Central Pacific is being watched closely as it moves west toward the Hawaiian Islands. The National Hurricane Center has placed a very high probability on it becoming a tropical cyclone, while meteorologists are still watching exactly how organized the circulation becomes and where the strongest winds and heaviest rain end up going. And here's the part that makes this interesting. A storm doesn't need to become a major hurricane to create a serious problem. Sometimes the biggest threat is rainfall. Sometimes it is the sea. Sometimes the center of the storm misses you completely, but the outer bands still create flooding, damaging surf, or dangerous conditions. That is why I want to walk you through what is actually happening instead of giving you another dramatic hurricane countdown. Because right now, the atmosphere is doing something that forecasters watch very carefully. A broad circulation is trying to organize. The winds are beginning to strengthen. The system is moving toward warmer water. And the Hawaiian Islands are sitting farther down the road. As of the latest available advisory information, the system had maximum sustained winds around 40 miles per hour with higher gusts, while the circulation was still broad and the thunderstorm structure was not yet well organized. The official outlook gave it a 90% chance of becoming a tropical cyclone within 7 days. That combination is what makes the next several days so important. And before we go deeper, tell me where you're watching from. Are you in Hawaii, the Caribbean, the mainland United States, or somewhere else? Because the tropics are becoming much more interesting right now, and I want to know where this forecast is reaching you. Now let's talk about why this storm is trying to develop in the first place, because the ingredients behind it explain almost everything we're about to discuss. The first thing you need to understand is that tropical storms are not created simply because the ocean is warm. Warm water matters, but it's only one piece of the puzzle. A tropical system also needs enough moisture, a favorable wind pattern, and a circulation that can organize instead of being ripped apart. Think of it like trying to light a campfire. You need fuel, you need oxygen, and you need the flame to actually catch. The warm ocean is the fuel. Moist air helps provide the material for thunderstorms. And the surrounding winds determine whether those thunderstorms can stack themselves around a circulation or get blown away. Right now, the Central Pacific system has enough ingredients to make forecasters believe development is likely. But there is an important complication. The storm is not beautifully organized. The official discussion described it as a broad, sprawling system with poorly organized deep convection and no strong curved banding structure at that time. Stronger wind observations were also found away from the estimated center, which made it difficult to identify one clean circulation. That might sound like good news, and in one sense it is. A storm with a messy center has a harder time intensifying efficiently, but messy does not mean harmless. In fact, broad tropical systems can sometimes reorganize very quickly when environmental conditions improve. Imagine a spinning figure skater whose arms are spread wide. The rotation is there, but the system is inefficient. Then the skater pulls those arms inward. The rotation tightens. That's similar to what meteorologists watch for in a developing tropical cyclone. If thunderstorms begin firing closer to the center, the pressure falls and the circulation tightens. The system can go from looking unimpressive to looking much more serious in a surprisingly short period. That is the possibility here. And there is another reason Hawaii is paying attention. The National Hurricane Center's guidance indicated that there is an increasing risk of wind impacts across the Hawaiian Islands, regardless of the exact track. It also warned of potentially significant rainfall, with forecast totals of several inches across much of the island chain and much higher amounts possible in the wettest areas. That means the question is not simply, will Hawaii get hit? The more useful question is, which islands get the strongest winds? Where does the heaviest rainfall set up? How much does the storm strengthen before reaching the islands? And does the circulation remain compact enough to concentrate its energy? Or does it stay broad and spread the impacts over a much larger area? Those details can completely change the outcome. And this is also why 5-day tropical forecasts can look frighteningly different from one model run to the next. A small difference in the steering currents can move the center dozens or even hundreds of miles. A small change in intensity can alter rainfall. A small change in organization can change the wind field. That's the hidden complexity behind those spaghetti lines you see on weather maps. They're not different storms, they're different possible futures. And right now there are still several of them. But one thing has already become clear. Hawaii is no longer looking at a distant blob of clouds that might someday organize. Forecasters are now treating this as a serious developing system. And the clock is moving. This is where I want people in Hawaii to slow down and pay attention, not panic. Pay attention, because the system is moving westward and conditions are becoming more relevant to the islands with every passing forecast cycle. The latest advisory information placed the disturbance roughly 895 miles east-southeast of Hilo and around 1,100 miles east-southeast of Honolulu, with movement generally toward the west at around 9 miles per hour. That sounds far away. And it is. But tropical weather systems are enormous. You don't need the center to arrive over your neighborhood before the storm becomes a problem. The outer circulation can begin changing ocean conditions well before land is directly affected. That's why surf is already part of the conversation. According to the advisory information, swells generated by the disturbance were expected to reach east-facing shores beginning Friday, with conditions building into the weekend. Forecasters warned that this could produce dangerous surf and rip currents. That matters because people often think about hurricanes only in terms of wind speed. But for islands, the ocean can become the first major warning. A strengthening tropical circulation pushes energy into the water. The waves travel outward. And long before the center arrives, coastlines can begin seeing larger surf and stronger currents. That creates a dangerous situation for swimmers, surfers, boaters, and anyone near exposed shorelines. Then comes the rain. And this may be the bigger story. The Hawaiian Islands have mountains. That is extremely important. When moist tropical air reaches steep terrain, the atmosphere can squeeze out enormous amounts of rainfall. A tropical system doesn't have to be a powerful hurricane to produce dangerous flooding on a mountainous island. You can have one side of an island getting manageable rain, while another side experiences dramatically heavier totals. That is why rainfall forecasting is so important. And according to the latest warning information available, the potential tropical cyclone was forecast to produce roughly 5 to 10 inches of rain across much of the island chain, with isolated totals potentially reaching 20 inches. Forecasters warned that such rainfall could produce life-threatening flooding and mudslides, especially across steep terrain. Now think about what that means. 5 inches of rain spread out over several days is one thing. 5 inches falling quickly over already saturated ground is another. 10 inches falling against steep mountain slopes is another level entirely. And 20 inches in isolated locations is a completely different situation. That's why a storm like this cannot be judged only by its maximum wind speed. A storm with relatively modest winds can still become a major flooding event. And if the storm slows down, rainfall becomes even more important. The slower the system moves, the longer the same area can sit beneath tropical moisture. It's like leaving a garden hose pointed at one section of ground instead of moving it around. Eventually, the issue isn't how strong the hose is. It's how long the water keeps coming. That's one of the reasons forecasters are closely watching the system's forward speed as well as its intensity. And now we get to the truly interesting part. Why is the forecast still uncertain if the probability of development is so high? Because development and impact are two completely different forecasts. Forecasters can have high confidence that a storm will form while still having significant uncertainty about exactly what it will do after formation. And that difference is about to become extremely important. If you've ever looked at a hurricane forecast and wondered why the predicted path keeps shifting, here's the reason. The atmosphere is not a highway. It's more like a giant river with currents moving in multiple directions at different levels. A tropical storm sits inside those currents. It gets pushed, turned, slowed, accelerated, sometimes trapped between competing systems. And one of the biggest steering factors in the Pacific is the surrounding pattern of high and low pressure. The developing storm doesn't decide where it goes. The larger atmospheric pattern decides. That's why meteorologists are constantly updating the forecast. Every new satellite image, every aircraft observation, every buoy report, every model run, every measurement changes the starting point. And when the starting point changes, the projected future changes too. This is why you should never look at one single model line and treat it like destiny. A model is a scenario. A collection of models is a probability range, and the official forecast is an expert interpretation of all of that information. Right now, the major story is that the system is likely to continue westward toward Hawaii, but the exact center is not locked in. That matters enormously, because imagine the difference between the storm passing directly over an island and passing 150 miles away. The storm could be the same storm, but the impacts could be completely different. One area might receive tropical storm force winds. Another might receive only heavy rain. Another could experience dangerous surf. And another could barely notice the storm. This is why I don't want you to think about this as one giant red line on a map. Think about it as a field of possible impacts. And the field is becoming narrower as the forecast gets closer. That is the normal process. Far away, the uncertainty is huge. Closer to land, the range tightens. That doesn't necessarily mean the storm becomes stronger. It means forecasters have more information. The current system is also interesting because it has not yet become a classic compact tropical cyclone. That gives forecasters another major question to answer. Does the circulation tighten, or does the storm remain broad? A broad system can still produce huge areas of rain. A compact system can concentrate its wind field more efficiently. And if the circulation becomes vertically aligned, intensification can become easier. That's what tropical meteorologists are watching for, not just bigger clouds. Organization. Is the convection wrapping around the center? Is the pressure falling? Are the winds increasing near the circulation? Is the upper level outflow improving? Those are the signs that tell you whether a tropical system is merely producing thunderstorms or actually becoming a stronger tropical cyclone. And there is another twist. The Pacific isn't the only basin getting interesting. The Atlantic is also becoming active. But the Atlantic story is actually a perfect example of why you should never trust a headline without checking the date. The reference material for this video described a tropical wave that was expected to become Tropical Depression Cristobal. That situation has already changed. Cristobal did form, meaning the forecast development occurred. And by August 13th, the system was becoming much less significant as a tropical cyclone. At the same time, another tropical wave farther east had an elevated chance of development. That is exactly how quickly tropical forecasting can move. Yesterday's developing system becomes today's tropical storm. Today's tropical storm becomes tomorrow's post-tropical low. And another disturbance takes its place. So when you see a dramatic headline saying a tropical storm is about to explode, stop for a second. Ask when that information was issued. Because in tropical weather, 12 hours can completely change the story. And right now, the Pacific system near Hawaii is the one demanding the most immediate attention. Not because we know exactly what it will become, but because the probability of development is already very high and the potential impacts are broad. While Hawaii gets most of the immediate attention from the Central Pacific system, there is another reason this week is interesting. The Atlantic is becoming active at the same time. The tropical wave that the original reference transcript focused on has already evolved differently than the earlier forecast expected. Tropical storm Cristobal formed over the Atlantic, while another disturbance farther east was showing signs that it could develop as it moved westward or west-northwestward. The August 12th outlook gave that eastern wave a 30% chance of developing within 48 hours and a 50% chance within 7 days. That's important because it means the Atlantic isn't simply quiet anymore. And we're approaching the part of hurricane season when the tropical Atlantic deserves more attention. One reason forecasters look closely at African tropical waves is that many Atlantic tropical cyclones begin as disturbances moving off the African coast. They can cross thousands of miles of warm ocean. Most never become hurricanes. Some fall apart almost immediately. But if the atmosphere gives one of them the right combination of moisture, low wind shear, and warm water, the system can gradually become organized. That's why a cluster of thunderstorms that looks completely harmless on a satellite image can still be worth watching. And it brings us back to one of the biggest lessons from the reference material. The atmosphere can contain competing ingredients. You can have warm ocean water, but too much wind shear. You can have moisture, but dry air nearby. You can have a strong circulation, but poor thunderstorm organization. You can have a tropical wave with lots of energy, but a steering pattern that sends it harmlessly into the open ocean. Everything has to line up. And when it does, development can happen surprisingly fast. That's why I don't want you to leave this video thinking there is one giant hurricane coming at everyone. That's not the situation. What we have is something more complicated. Several tropical systems, different levels of organization, different environments, and several possible outcomes. In the Caribbean, the most immediate concern from the current Atlantic setup is not automatically a major hurricane. Rainfall can be the bigger issue. Tropical waves can produce heavy showers even when they never become named storms. That's particularly important for mountainous islands, where intense rainfall can run off quickly and create flash flooding. It is also important for communities that have already dealt with drought. Rain is not always a bad thing. A tropical wave can actually be beneficial when it brings needed moisture without producing destructive winds. That's one of the strangest things about tropical weather. The same system can be dangerous in one place and desperately needed in another. One island can be dealing with too much water while another is begging for rain. So the most useful weather information isn't always the most dramatic. Sometimes the important message is simply expect rain, expect rough seas, expect gusty winds, watch the latest advisory, know whether you're in a flood-prone location. That kind of preparation doesn't make for the biggest thumbnail, but it can make a huge difference in real life. And that is why we're keeping this discussion focused on impacts instead of trying to guess the strongest category a storm might reach. Because categories can change, forecasts can change, but preparation is useful regardless.